Hello everyone. Have you ever wondered about the signification of your mistakes? It is always discouraging to admit what you've done wrong, what you should have done instead, and what you should do next time. In life, you always strive to make the least amount of mistakes as possible, and that's normal. But what if I told you that there is a domain where doing mistakes or not obtaining what you wanted can be beneficial? Yep, that's research. In fact, when we think about research, we always think about great discoveries. Heliocentrism, the universal law of the gravitation, general relativity, or even RNA COVID vaccines. However, we don't often think of mistakes in research. Well, apart from the example of Alexander Fleming, who discovered penicillin by accident, just by letting a culture plate a little open during summer break. Well, for a mistake, that is one for sure. In biology studies, it is always told that we should be the most careful about sterility of our cultures. So, letting a culture plate open for just several seconds is considered a mistake. And here, they found the first antibiotic just by doing the opposite of what they should have done. Now, we can't really make mistakes on purpose, just to hope to discover something revolutionary. Our director would fire us and no organization would fund our work. However, what we can do is ask the good questions. And if something strange happens, then really think about it. Now, I would like to tell you a little story about an experience that I had in my lab during an internship, and which I find particularly interesting to support the point that I want to make, which is it good to not obtain what you wanted? So, I was studying an enzyme, which is a little molecular machine that enables reactions to be done in a living organism. And this enzyme is present in yeasts and is called SDT1 for suppressor of disruption of TF2S1. You really don't need to remember this. But what you should consider is that in 3 different papers, this enzyme was called a pyrimidine and pyridine-specific 5' nucleotidase in S. cerevisiae. Okay, thank you, but what do these excruciatingly hard to read words mean? Well, 5' nucleotidase means that this enzyme cleaves a certain type of molecules, called nucleotides. These are the base material for DNA or RNA, as the N in their names indicate, nucleic for nucleotides. Then pyrimidine and pyridine specific stands for the fact that among all nucleotides, SDT1 only cleaves pyrimidines, which are the nucleotides with only 1 cycle, compared to purines, which have 2 cycles. Finally, in S. cerevisiae, just means that this statement can be considered true in a specific kind of yeast called Saccharomyces cerevisiae. But here, our work consisted on verifying what reactions can be done by SDT1 in 3 other yeasts, which are C. albicans, C. auris, and N. glabrata. Now, long story short, we did an experiment to verify which molecules SDT1 could cleave in these 3 yeasts. We were particularly looking at nicotinamide mononucleotide, which was our subject of study. But we also put in other molecules that we had, because our plates enabled us to do this analysis on 8 different molecules. So we also looked at DCMP, DTMP, DAMP, DGMP, IMP, and XMP. The first 4 are deoxynucleotides. And so we already kinda knew that they would not be hydrolyzed. And it was no surprise to see that they were not cleaved, in fact. But what for XMP and IMP? Those 2 molecules only have 1 phosphate, so they could potentially be cleaved. And here we see that in all yeast, XMP is really hydrolyzed, or at least a little bit, and IMP just a little bit. But what do XMP look like? I asked myself. I looked it up on Wikipedia and saw this. A purine. What the heck? It wasn't supposed to do that? Did I wrongly perform this experiment? Do I have the right enzymes? Should I tell this to my supervisor? Maybe XMP just stands for something else. No! In fact, we verified and SDT1 seems to really cleave XMP. What a discovery! This is in complete disagreement with this sentence from earlier. SDT1 is a pyrimidine and pyridine specific 5' nucleotidase in S. cerevisiae. But okay, we didn't look at S. cerevisiae. But now I want to do this. You can see that something that we didn't expect at all brought a lot of questions, and it also questions the work of other people. Unfortunately, my internship ended just after that, and I won't be able to give you more details about it. But if you're interested, go check it out by yourself. And don't forget to ask good questions. See you next time!